All right, here's a problem asking us to calculate for the moment of inertia of a solid sphere. So we have our 12 centimeter diameter solid sphere with a mass of 21 grams. We want the sphere's moment of inertia for rotation about an axis. So two different axes. First, we want the axis to be through the center. Second, through the edge. All right, so we need the radius. So that will be 6 centimeters, which SI units, we will want that in meters. The mass we will want in kilograms for our SI units. All right, so a sphere, that's a very terrible sphere. I apologize, my artistic skills are terribly lacking. So it's telling us the axis should go through the center of the sphere. Now, the one on the test notes or from the book, the axis comes towards us. Since it's a sphere, it doesn't matter, because coming out from the middle in any direction, the mass will be distributed the same way. If you refer to the table, either in your book or in the test notes, it tells us that I, for a solid sphere, about its center, because they show the axis going through the center, the equation for that is 2/5 mr squared. So, just plugging our numbers in, our mass, 0.021 kilograms, our radius needs to be squared. It's going to be a very small number. I'm going to write it in scientific notation. So 3.0 times 10 to the negative 5. The units, well, the mass was in kilograms. The radius we have in meters, and we squared it. So our answer for part A is 3 times 10 to the negative 5th kilogram meter squared. Part B, we have the same sphere, but it says it wants to know the rotational or the moment of inertia around an axis through the edge of the sphere. So we have a different axis, a new axis. This one, if I look at the table, it does not tell me the equation for I around the edge of a sphere. But this new axis is parallel to the one that goes through the center, so we can use the parallel axis theorem, which I knew this new axis that does not go through the center is equal to I through the center of mass plus md squared. Now, technically, we've calculated I through the center, so we can just use that number. That's fine. And then m is 0.021. The distance, d, the distance we've shifted. So from the center to this new axis, d is the radius of the sphere if we shift all the way from the middle to that outer edge. So 0.06 squared. I'm getting 1.1 times 10 to the negative 1, 2, 3, 4. And the units are still the same, kilogram meter squared. So part B, this is bigger Because now the sphere is all shifted away from the rotation axis. So that big shift in mass away from the rotation axis increases the moment of inertia. So the disk would be, the sphere, this would be harder to change its motion compared to getting a sphere to roll or rotate around its center, just in comparison.